Hello to all my young friends who are studying in intermediate and they are watching this video. And welcome to this series of Calculus Made Easy. In the last video, we discussed about intervals and neighborhood, which all the topic was simple, but it was required before we start discussing calculus. And today, in this video, also we are going to discuss one more important topic, which is very much essential before we start discussing calculus. The name of the topic which we are going to discuss today is relations and functions. Now, as we already said in our introductory note, that calculus deals with study of continuous change, and change can be studied by establishing relationship between different variables, and the relation for which every input there is only one output is called a function. And calculus deals mainly with the study of functions. So let us understand functions and relation, because with this statement you can conclude that how much important this relation and functions are in calculus. So let's understand them. Now, what is a relation? Basically, if you see by definition, in mathematics, it's a way of establishing relationship, connection between any two objects or things, or somewhere it is also written that between elements of two sets, that is in set theory, you must have read it. Like, for example, this is a set where we have elements a1, a2, a3, a4, and there is a set B where we have elements b1, b2, b3, b4, b5. Suppose a1 corresponds to b1, a1 corresponds to b3, a2 corresponds to b2, a3 to b4. There is maybe some kind of relation. So this is a relation which we can show it like this. So let me explain with another example. Suppose there are two sets, x which has 4, 36, 49, 50, y which has 1, minus 2, minus 6, minus 7, 7, 6, 2, and we say there is a relation. It is defined as x is equal to y square. That means 4 will correspond to 2 as well, or minus 2 as well as 2, because the square of minus 2 is also 4 and 2 is also 4. So we can show it like this. Again, 36 will correspond to minus 6 and 6, 49 minus 7 and 7. So this relation can be written as 4 minus 2, 4, 2, 36 minus 6, 36, 6, 49 minus 7, 49, 7. We can write it like this. So these are called ordered pairs, where the first element belongs to this set x and the second element belongs to y. We can write it as an ordered pair. This relation can be represented as an ordered pair. Now, relation is a subset of Cartesian product. This is a statement which we are making. Now, what is a Cartesian product? Cartesian product of set x and y is represented as x cross y, and this cross should be small, x and y are big, such that it contains all the ordered pairs x and y, where x belongs to this bigger set, capital X, and y belongs to capital Y. So let me explain you what does it mean. Suppose this is a set x which has a, b, c, d, and y which has E, F, G, H, I. Now, how many possible ordered pairs are there if we take x cross y? A can be mapped to E, F, G, H, I. It can be written as A, E, A, F, A, G, A, H, and A, I. Right? So we'll write it like this. Similarly, for B, these ordered pairs. Similarly, for C, this many ordered pairs. Similarly, for D, these many ordered pairs. There are all possible ordered pairs for a relation from X to Y. This total set, this whole set is called the Cartesian product of X and Y. So what we are telling, that relation is a subset of Cartesian product of two sets. Now let me, explain it with an example, although I think most of you must be clear with this, but still. So we can easily see that, and this is the example which we discussed 2 minutes back. Here, the relation is these ordered pairs. But if you see the Cartesian product, there will be 4, 1, 4, minus 2, 4, minus 6, then 36, 1, 36, minus 2, and similarly for 49 and 50. So I have written it here. So this is the Cartesian product of X and Y. So you can see that this relation R is a subset of this Cartesian product of X and Y. So we can easily see that relation R is a subset of Cartesian product. Now, what is a function? Function is a relationship between one variable which is independent and another variable which is dependent variable, such that whenever a numerical value is assigned to x, there is a rule that only unique value of y is determined. That means it is written as y is equal to fx. This is x is independent variable, y is dependent variable. For a single value of x, you can only have one value of y. For example, if y is equal to 2x plus 1, say x is equal to 1, y is equal to 2 into 1 plus 1 is equal to 3. So for one value of x, there is only one value of y. So this is a function. But if we have a relationship like this, y square is equal to x. Now, if x is equal to 4, y can be minus 2 and plus 2, because the square of minus 2 also is 4 and plus 2 also is 4. So that is not a function, it's a relation. Now functions are ubiquitous in mathematics. What is meaning of this term? Means they are found everywhere and are essential for formulating physical relationship in sciences. So they are found everywhere. And the modern definition of function was first given in 1837 by a German mathematician, and his name was Peter Dirichlet. Every function is a relation, but every relation is not a function. Example, you just saw this example, x is equal to y square, which we discussed just now. Here, you can see for the same value of x, that is 4, you have two values of y, -2 and +2. So this is a relation, but it's not a function, right? So every function is a relation, but every relation is not a function. Now, what is domain? Domain is all possible input values. For example, if you have a function y is equal to fx, so all possible values of x, the set of all possible values of x is called domain. These are certain terminologies which we will be using very often. Other terminology is codomain. All possible function output values. And the third, range. All actual output values. That is called range. For example, if we have a function y is equal to fx, so what all values of x we can have, that set is domain, and correspondingly the values of y which we get, that is called range. Now, what is then codomain? We say that all possible function output values. Here, many people are confused. So, let me explain. For example, if these are two sets and we have a function like this is a function. So, here you can see this is the domain, the values of x. As the total set is called codomain, and the corresponding value of y which we get is range. I think to some extent it is clear. So we can easily see that the range is always a subset of codomain. It can be equal to codomain in some cases, but it's always a subset of codomain. It's always smaller, or it can at the maximum will be equal to codomain. But let me just clarify this doubt which many people have, as they are not able to differentiate between codomain and range. So let me give you one example, one interesting example by which you will remember this codomain and range. Now, game of cricket is very popular these days. So let me give an example from that game. Suppose four balls are to be played in a game of cricket with more than four wickets in hand. So what is the input? Input are four balls, B1, B2, B3, B4. Now what are output possibilities? The batsman can hit it for a 6, 4. He can take singles. There can be a dot ball. The batsman can be out. I'm not considering no ball. Just a hypothetical case. Now the first ball is bowled. The batsman hits a 6. On second ball again, it's a 6. Third ball, he takes a single. And fourth ball, he hits a 4. Now the input are these four balls, which is the domain. And the actual output we got is range. But the possibilities is the total set. Means 6, 4, singles, dot ball, and out. So that is codomain. Now don't connect it mathematically. This is just to explain you in an interesting manner. That's it. I think now you'll be clear with what is the difference between codomain and range. Now suppose we have a function which is defined like this. So this is domain and this is codomain, and DEF is the range. So we also write it like this: function A to B defined by y is equal to fx, where x belongs to set A, right? So we also use this notation. So you should be clear with this notation. So here A is domain